Hello and welcome back to, well, we're not in the power shed, we're in my garage and we're up in the attic. This is kind of my office. I haven't used it for much, mostly just storage. I have a lot of stuff piled up, but it's a nice little room. Yeah, I got scenery. And one of the things I wanted up here is some AC power. And this is my latest purchase. It's a 60 volt to 220 50 hertz inverter, and these are hard to find in the United States, but if you look around you can find them. 60 volts is very popular in Europe, and I don't know why. If you have 5 batteries, 5 12-volt batteries, which would take the power of this, why would you have a 500 watt inverter? They advertise this in one place as 2,000 watts, and some place it's 500. Well, I mean 1,000, and inside it has a single 500 watt transformer, so it's really just a 500 watt unit, but it's fine for powering a lot of electronics. Most of my electronics has an input, has switching mode inputs, and they'll take from 100 to 240 volts. And actually a lot of my stuff I even run at 60 volts, or this little power supply here is running at 160 volts DC. I got that little inverter, and it went bad. I never bothered to repair it. I just pulled out the H bridge and ran DC out to the outlets, because that's what these things like, and you don't get any of that switching inverter noise. But anyway, I bought this thing, and this doesn't look anything like what the listing was on eBay. It's physically different, but it still has the four USB sockets, and it has a voltage input and a voltage output. When I first hooked the thing up, I was expecting that the voltage input one was actually wattage, and it said 64.5 or something like that, and I was thinking, like, is that the idle watts? It seems kind of high, or just a bad calibration. But it was actually the voltage input, which is kind of convenient, so I can look at my array right there. I normally run a 60 volt array because I have extensive shading. I have five strings in parallel, and well, with all this Chinese stuff, it's really nice, but this uses those universal sockets that will take European, US, whatever, and they're total crap. They don't have a ground pin, and when you push in a plug, you feel like you're going to snap it. It takes so much force. It's got a power switch up in the front, turn it on and off, but it's also got a power switch on the side, which isn't connected to anything, but it's there for another use, and I do have another use. You'll see that in another video. But I'm running this off my 60 volt array, no battery, and hey, it works. But it's 220, and I do have some things, some analog power supplies, which are only 120 volts. And so I wanted some 120 volts for that, so I made this little box. And you see it has 2 capacitors on it, and it's got 2 sets of outlets. And this is a stupid engineer trick. Normally in these inverters you have 2 half-bridge drivers, and so it's driven as a bridge, and you have 220 volts across it. Well, instead of, I only use half of it, and I use these 2 capacitors in series. They're 1200 UF, 200 volts. And I have a couple of resistors for balancing them. The leakage may be a little bit different on each capacitor. But if there's any imbalance in the circuit, those capacitors will take care of it. So normally what you have is, you have a pulse going positive for 8 milliseconds, and then 2 milliseconds off, and then another 8 milliseconds going negative, and then another 2 milliseconds off, and then repeats going back positive and negative. And as you can see, 20 milliseconds, that's 50 hertz. So it's a 50 hertz inverter, but stuff doesn't really care. So what I've done is I have the scope actually plugged right into the 220, and that's the little waveform. It's not perfectly square. As I said, the waveform you're getting is 12 milliseconds positive and 8 milliseconds negative. But that's fine enough for government work. I feed the box off this side with a, that takes the 220 volts and brings it to that, and I connect that to the two hots of the terminals. And for the neutral side, I connect it up to the bridge, and the thing works fine. It's kind of neat. I'm going to show you this. This is my little HSPY power supply I got. This is the one that was $36 shipped with taxes. I mean, it's really nice. You can, it's really purely digital, and I can go in and set, I can move the tens digits, the singles, the fractions, and set it all up, turn it on and off. Really nice. Give me a second and I'll open this thing up for you. I remember there was a cartoon where this box had a label on it that says warning shock hazard, and then when you opened it up there was another little label that said we told you you'd be shocked. So here's these connectors. As you can see, the ground pin is right there. It's not connected to anything. This is the AC going out that's coming right from the board, and then from the plus and minus I go right off the power supply. So conveniently I can tap onto this resistor, and over there there's a positive of the diode, and I connect right on there. Pretty simple inside. Like I said, there's the switch, nothing connected to it, but I got a use for it. So yeah, give me another second and I'm going to hook this up to the power supply. We all know that it's a 60 volt inverter, but what does that mean? There were no specifications on this at what it would turn on and off at, so I had to do the test myself. So we're connected once again, and you can see my little, ooh, that looks like a short almost. And we've hooked up the power supply to this. I'm not sure how well the screen comes off, but we're at 62.5 volts, and I'll just keep turning down the voltage. We're at 58, 57, 56, and if you can see, we're only drawing about 1.32 amps. It's up to about 1.55 up at full voltage. Well, 45.5 it stopped. Now I wouldn't normally run it that low, but that's how it works. So yeah, it's 0.155 amps at 62.5 volts. It turns off around 45, 46. It's 9.7 watts at idle normally, and it turns back on at 57.5. I'm not sure if that's actually right. My power supply goes into current limit. It's only a 1 amp supply, and it keeps cycling, but at that 57, 58 volts, it's got enough voltage to turn on. So, but anyway, it's the turn off we really worry about. So that's my video. Thanks for watching.